Hello, in this lesson, I'm going to introduce you to geometric proof. Before we start, let's kind of do a little review of what algebraic property you learned in your algebra classes. So the first one is property for equality. So if I have an equation, I could add a number to both sides of the equation, subtract, multiply, or divide a number on both sides of the equation, and the equation still hold truth. So when I add a number to both sides, we call addition property equality, that we add anything to both sides. If I subtract, subtraction property equality, multiply, multiplication property of equality. And when I divide, I just need to make sure I don't divide it by a number by 0, which is called division property equality. So this is for algebraic property for equalities. Now let's look at the next big section, which is algebraic property for equality. The topic is general. So when I say the other one would be reflexive property, I use reflexive property. I say A equal to A, a number equal to self, or angle equal to self. This is reflexive. Symmetric property, A equal to B equal to A, kind of makes sense. 3 equal to 4, 4 equal to 3. You can revise the order. So, and then distributive property, we could distribute both sides and so forth. This is called distributive property. And then there's substitution. Substitution is something that used pretty common. I'm basically replacing A with A replaced with B in any equation. If A equal to B, I can replace A for B or B for A, vice versa. A substituting equivalent expression. Transitive property, A equal to B, B equal to C, therefore A equal to C. It kind of reminds us what we learned in previous unit. We talk about the law of serialism, where A implies B, B implies C, therefore A implies C. But back then we say PQR. So P implies Q, Q implies R, therefore, P implies R. Same thing here. It's similar to transitive property here. So those are property that are for algebraic property of equality. Next thing is for inequalities. For property for inequality, we could equality, I could add a number to both sides of my inequality. My inequality sign still hold true. Again, I could also subtract a number to both sides of our inequality, still hold true. Notice that we do not have a multiplication and division property inequality. And the reason for that is if I multiply a negative number to an inequality or divide a negative number to an inequality, I have to reverse the inequality sign. And that's why we do not have multiplication and division property for inequality. So those are property I could use for as part of reasoning in my proof. So let's just do a very example to how to use those properties. So first thing is this is called two-column proof, where you write a statement on the left, write a reason on the right. So let's just see again. We can solve an algebra question, I think. Algebra just add like we do normally do, but only difference is here is add my reason on the right hand side. So for this question, I need to prove that x is equal to 2. So step 1, I always write down what is given. So 1, I have 4 times 2x minus 1 plus 3 give me 15. Okay. So this one here I'm given. So my reason is the direction given to me, I write given. Okay. Next. Now, how will you solve this question? I could subtract 3 to both sides. Some say, oh, I want to do the distributive property first. So whichever way you do it is totally fine. So let's say I subtract 3 to both sides. So if I subtract 3 to both sides, I would have 4 times 2x minus 1 is equal to 15 minus 3, going to give me 12. Since I subtract from step 1 to 2, I subtract 3 to both sides. So I say subtraction property of equality. So subtraction property of equality. I'm going to abbreviate that. Next, well, what can I do to solve this equation here? Some say, yeah, I want to do distributive property. We could do that. Or we could say, just your method. I could just divide both sides by 4, works same way. So let's divide both sides by 4 here. So if I divide both sides by 4, notice that I would have 2x minus 1 on the left because I multiply 4 here. 12 I divide by 4, gonna give me 3. Well, divide something to both sides of the equation, and in this case, divide by 4. So division property of equality. Okay. Next thing, well, what can I do to solve this equation? Just an algebraic equation. I'm subtracting 1 here, so I need to add 1 to get rid of, to make 2x by itself. So I'm adding 1 to both sides of the equation. So step 4, adding 1 going to give me 2x on the left. 3 plus 1 give me 4. I'm adding a number to both sides, so it's addition property of equality. Okay, so addition property of equality. Okay. Next thing, well, what can I do to solve for x? Well, divide both sides by 2. Okay. So I would have x equal to 2. So I divide both sides by 2. Therefore, numbers 5. This is called division property equality. And I have x equal to 2, which is exactly what I need to show. Okay. So that's it. Solving, we use that reason. We solve all the time. We know we could do add, we could subtract. We just never really write down the reason in your algebra class. But this is a 2-column proof. Now let's move on at example 2. Now in this example 2 here, I'm given E is the midpoint of DF. I need to show that DE equal to half of DF. Basically, I need to show that the midpoint divides the line segment into 2 congruent parts, right? So which is divided equal parts. So let me draw a little picture to represent that. So I have DF. So this is my DF. This is D. This is F. And I have E is the midpoint of these two. So E is the midpoint. Again, the midpoint right in the middle, an equal part. That's what I need to show. So I need to prove DE is equal to half of DF. That's what I need to show. So what do you think I need to do first? I will suggest that you maybe pause the video a little bit before you do this one. Okay, I hopefully by now that you paused the video, you had tried it, and now let's do it. Okay, so first thing is, we make a plan for it. We know that midpoint kind of divide your segment into equal parts here. So we kind of know that, we know that. But how we know make DE equal to half of DF here? So in this case, so first thing, let's just write down a given first before we actually make it. So I'm gonna write down a given. 1. So E is the midpoint. The keyword here is midpoint of DF. Okay. Well, this is given to me. Given. Well, what do we know about midpoint? Midpoint, by definition, we say midpoint divides a segment into equal parts. So since E is the midpoint, this tells me that this part have to equal to the other part. That's what midpoint, it means. So therefore, step 2, I could say, you know what? Midpoint divide my segment into equal parts. I could just say DE, okay, DE and EF have equal length. And that is just a midpoint. So I could write my reason as midpoint separates a segment into 2 equal parts. Just write it. So midpoint separates, abbreviate that, or cuts, write it in your own words. So separates a segment or line segment into 2 equal parts. Okay. Now again, my goal is to get DE by itself on one side. Well, I have DE already. Okay. And next thing, I need to have DF. Well, let's look at DE and DF. What is the relationship between DE and DF? Let's think about it. DE over here, DF is the whole thing. So DE is part of DF. So if that means I can rewrite it using somehow involving DF. For writing an equation involving DF, I could say DE plus EF give me DF. The 2 smaller segment here gonna give me the big one. So next step, I can say, well, let me write down based on that. So again, my goal is to write equation involving df, right? So by looking at this, I say, well, these two small parts add up to the big one. So I say de plus ef is going to give me df. And number 3, and we call that when I'm adding two smaller segments add up to the big segment here, it's called segment addition postulate. Okay. Again, now I have equation involving dE. I also have equation involving dF. Now let's see, look at this, what we have so far here. My goal is to have dE and dF in the same equation. Look like I have it. I have dE and dF in the same equation, which is what I want over here. I look at what I want at the same time. I know that I have dE, I have dF, but the only thing right now I have extra here in my equation is EF. Well, what can I do to get rid of the EF here? Well, we know EF is equal to dE. So instead, right, I'm going to replace EF with dE. So I substitute EF with dE. So next step, number 4, I have dE plus dE is going to give me dF. Now notice that I write dE twice there. So this is not by accident. So dE, let me highlight so you see it. I replace the EF with dE. The reason I could replace it because they have equal length. They're the same, basically, equal length here. So, and number 4, when I replace something, basically I'm substituting something. I'm substituting dE here. So this is called substitution. Well, I want to tell my reader what am I substituting. So I'm substituting using step 2 and step 3. So let's put a note to my reader here. I'm substituting using step 2 and step 3. Well, now again, I have 2 dE now. So let's say dE plus dE. Well, we know what will give me 2 dE. So I have 2 times dE in the next one. Number 5 is that x plus x give me 2x. Well, dE plus dE give me 2 dE. So I have 2 dE. Okay. Again, dE is a length, so I can just add them. So this is dF. And number 5, well, here I'm substituting again. Note that dE plus dE give me 2 dE. I'm not adding dE to both sides of the equation here. One common mistake I see in these steps, a lot of kids say, oh, I'm adding a number, therefore addition property of equality. But remember, addition property of equality tells me I'm adding a number to both sides of my equation. But here, I'm not. I'm basically simply replacing an equivalent expression with what I have here. So this is T1 here is the same as this one. I just rewrite it using a different expression. So this is called substitution because I'm replacing it with a different expression. I'm substituting it. So substitution. Okay, substitution. I'm using 4 here. I'm basically replacing, rewriting it, I think. So you can create substitution. Or in algebra class, I think we learned it called combined like terms, we say it. So now number 6. Well, remember my goal is to solve for dE. I want dE by itself on one side. So next step, I could just divide 2 to both sides. So I say dE is equal to 1/2 of dF. Okay, dF. I divide both sides by 2. And number 6, so this is called division property of equality because I do it to both sides. And look at my statement, look at what I need to show, and this is exactly what I need to show. And this completes the proof. Thank you for watching the video. See you next time.